Yesterday we just practiced setting up our trig ratios. Today we are going to actually use those trig ratios to help us solve for missing sides in our triangles. So first of all, if we were looking at these figures here, if this is the only angle that they give me, that must be the angle I'm using as my point of reference. Okay? So, which side is opposite of that 36-degree angle? Right. So this would be my opposite, which would be the adjacent. Good. And we would know the hypotenuse must be this side here, right? Okay. If this angle of 32 is my angle of reference, which side is the adjacent side? Good. And what's my hypotenuse? Good. Which means CB must be our opposite side, right? Okay. On this last drawing here, which side is the opposite? Good. And adjacent? Good. Which means AB must be our hypotenuse, right? Okay. So, remember yesterday we talked about the acronym that helps us to remember SOHCAHTOA. So SOHCAHTOA is our acronym. It represents all of our different ratios. So sine comes from SOH. What is the ratio for sine? Good. So sine of theta is equal to opposite over hypotenuse. Okay, what's the ratio for cosine? Right, so cosine of theta is equal to adjacent over hypotenuse, and tangent of theta is equal to, good. All right. So, now we are going to look at using one of these ratios to actually find a missing side. So in yesterday's assignment, they gave you all the numbers of the sides, right? You were just simplifying. Today we're going to solve for missing sides. So, the first one we're going to talk about using is sine, which comes from that SOH. Like you guys said, sine is opposite over hypotenuse. So, in this figure, when they ask us to find a missing side using sine, instead of theta, they did give us an actual angle to use, right? So, instead of sine of theta, I'll put sine of 54 degrees is equal to that ratio that we know, opposite over hypotenuse, right? Okay, which side is the opposite side here? CB, good. Over the hypotenuse, which is which side? Good. Now, in the problems where we're solving for missing sides, there are going to be actual numbers on one of those two sides. We're going to be looking for the other, okay? So let's see here. On this first example, what is the degree of the angle that's given to us? 54, okay. And these are all sine examples, so we are going to use sine. So I'm going to have sine of 54 degrees instead of sine of theta is equal to, like you guys told me earlier, opposite over hypotenuse. Okay? So, looking at this drawing, what is the side that is opposite of my angle? X. So I would have x over, what's the length of the hypotenuse? 11. Okay, so basically what I have here is sine of 54 is equal to x over 11. Now we only know how to solve for one variable at a time, right? So if I'm going to be solving for x, I need to turn sine of 54 into just some number, right? So, remember yesterday in our calculator we talked about how to do that. As long as it is in the degree mode, all we have to do is type sine of 54, and it converts it to a decimal for us, right? Okay. Now, we're only going to go 4 decimal places whenever you are using what you get from your calculator. However, I also gave you a trig table to pick up when you walked in. So, if you look at your trig table, it has the value for the degrees converted to decimals on this table for you, okay? So, if I'm looking for sine of 54, here is 54, right? And I look at where that meets the sine column. Well, this is the sine column, so here is sine of 54, okay? And that is the exact same thing our calculator gave us, right? Now, most of the time they should be exactly the same. Obviously, depending on if your calculator is set to some sort of a different float, it could change it maybe a decimal or two. But we're always going to go 4 decimal places, whether you use your calculator or whether you use the chart, okay? All right, so either way, we know that in place of sine of 54, we can write it as 0.8090. So, in place of sine of 54, I have 0.8090 is equal to this ratio, x over 11. Okay, and we just want to solve for x, so what are we going to do here? Right, so you can either think of that as, okay, I'm going to multiply both sides by 11, or you can put this over 1 and cross multiply. Either way, it's the exact same thing, right? I multiply this direction and I have 1x. I multiply this direction and we have 11 times 0.8090. Approximately, what's that going to give us? 8 point what? Good. 8.899 would be the approximate length of that side that is labeled x. Okay, let's just go ahead and say that for all of our answers, we're going to go 3 decimals. You can write that above if you'd like. Okay, all right, so let's do another one. For the second example, what is the angle that they gave us? 32. So I'm going to have sine of 32 degrees is equal to opposite over hypotenuse. Okay? So what is the side opposite of 32? Good. And the hypotenuse is? Good. Okay. So I need to convert sine of 32 into a decimal. You can either do that in the calculator or you can just look on your chart. So sine of 32 would be right here. That'd be 0.5299, right? All right, so I have 0.5299 is equal to 29 over x. And just like last time, I'm trying to solve for x, so I either am going to have to multiply both sides by x to get it out of the bottom, or you can think of just putting this over 1 and cross multiply. So x times 0.5299 is just 0.5299x is equal to 1 times 29, which is just 29. And then what would we need to do? Very good. And when we divide 29 by 0.5299, approximately what do we get there? Very good. All right, we got one more. So there's my angle. So how am I going to write this equation? What's it going to look like when we set it up? Good. Right, and what is the opposite? Nice. Okay. So now we need to convert sine of 49. What would sine of 49 be as a decimal? Very good. Is equal to that 15 over x. And then what are we going to do to solve? Put this one over 1 and cross multiply. So I have 0.7547x is equal to 1 times 15, which is just 15. And what would we do last? Very good. And what do we get when we divide? Very good. Okay. So, there are some examples using sine to solve for the missing side. If you'll flip it over onto the back, now we're going to look at some examples using cosine. Okay, so in this figure over here, we've got a 38-degree angle. What is the ratio for cosine? Good. Remember, C is equal to A over H. Okay, in this drawing over here, which side is adjacent to that angle of 38 degrees? Which side's adjacent to 38 degrees? CD. And what's the hypotenuse? Good. All right. Now we're going to actually have some value to substitute in for one of those, and we'll find the missing side. All right, so on the first example, my angle is 51 degrees, and I only have the adjacent and the hypotenuse, so I have to use cosine, because I don't have enough information for anything else. So I'm going to have cosine of 51 is equal to, our ratio is adjacent over hypotenuse. Okay, well, what is the side adjacent to 51? Good. And the hypotenuse is nice. Okay, so now we need to convert cosine of 51. So what is cosine of 51 as a decimal? Now, you also, I do want to give you guys another option for this. So you can look on your chart here, 51, it's 0.629. So you can go ahead and convert it just like we were doing on the front page. You also, if you are preferring to type in your calculator, can leave it as cosine of 51 is equal to that x over 17. And what am I going to do to solve for x here? Right, so you could, in your calculator, type in 17 cosine of 51, and it would solve it for you all at once. Okay, so what I mean by that is you could type it in as 17 cosine of 51, and you're going to get the same answer as if you had just gone ahead and changed it to a decimal from the beginning. So it's kind of a preference, whichever way you prefer to go about it. But we should get the same answer either way. All right, so whenever we solved here, we should end up with x was equal to 10.698. Okay. All right, second drawing here. So here's my angle. What's this one going to look like when we set it up? Cosine of 27 equals that adjacent, which is the 19, over hypotenuse, which is x. Okay, and just like on the front page, you either think of it as multiplying both sides by x and then dividing, or just put it over 1 and cross multiply, right? Okay, so if you are not typing this in your calculator until the end, when you cross multiply, you'll have x times cosine of 27 equals 19, right? And then you're trying to get x by itself, so you divide by cosine of 27. So you'd have 19 divided by cosine of 27. So in my calculator, alpha y equals, enter. I've got 19 divided by cosine of 27. You also can just put in parentheses your denominator if you don't want to make it the actual fraction. Either way, we get approximately 21.324. All right, last one in this section. What is our equation going to look like for this one? Cosine of 44 equals what? So what's the ratio for cosine? Adjacent. And which side is adjacent to the 44? X. Right, so X over 25. All right, and I can put this over 1. Oops, I didn't mean to add an extra. All right, so I put this over 1 and I cross multiply. So this direction, I've got 25 times cosine of 44 equals 1 times x, which is just x. Okay. So then in my calculator, I type in 25 cosine of 44. Uh-oh, my calculator just froze. All right, so whenever we type that into our calculator, approximately what did we get? Very good. All right, and then the last ratio that we haven't practiced using is tangent. Tangent, remember, comes from the TOA in our acronym SOHCAHTOA. So what is our ratio for tangent? All right. All right. So in this drawing over here, which side is opposite my angle of 20? Very good. And what's adjacent? Good. All right. So we're going to look at these last 3 examples here. So the first one, my angle is 63. I only know opposite and adjacent, so I have to use tangent. No other option. So I have tangent of 63 is equal to, where we're going to have opposite over adjacent. And what's my opposite side? 9. And the adjacent side is correct. Okay? So I can put my tangent of 63 over 1 and cross multiply. So I have x times tangent of 63 is equal to 1 times 9. And then I just need to divide by tangent of 63. So I'm going to have x is equal to 9 divided by tangent of 63. What do we get when we divide those? Very good. Okay. Okay. On the second drawing, here's my angle. What's my equation going to look like when we set it up? Good. Tangent of 25 is equal to x over 23. All right. So I put this over 1, and we cross multiply. When we multiply this direction, I've got 23 times tangent of 25 is equal to 1 times x, which is just x. So what is 23 times tangent of 25? Good. All right, last one. Here's my angle. So what's my ratio going to be? Put it over 1 and we cross multiply. So I have x times tangent of 32 is equal to 1 times 25. And then what do we do? 5. So x is equal to 25 divided by tangent of 32. So approximately what is our x there? You said it's 0, 0, what? 6 is what we got? All right. So they are not always going to tell you which ratio you have to use. But if they only give you adjacent and hypotenuse, what do you have to use? They only give you adjacent and hypotenuse. What are you going to have to use? Cosine, right? If they only give you opposite and adjacent, what are you going to have to use? Tangent, right? If they only give you opposite and hypotenuse, you have to use